I'm Joshua Bardwell, and you're going to learn something today. It's another video in my series on how to wire up your flight controller. Yes, your flight controller, specifically. But wait, I don't know what flight controller you've got. Well, it turns out they have enough in common that if you know what to look for, you can figure out pretty much how to wire them up. And I'm going to show you how. Today, we're talking about your FPV gear, your camera and your video transmitter. Stay tuned. I'm about to show you how to wire up your FPV camera and your video transmitter. And although it seems really simple, I think you just wire them up, right? This is actually one of the more complicated sections we've gone through because, well, you'll see why in a minute. But before we dive into the content, I want to remind you, in case you've stumbled across this video randomly, hi, nice to meet you. This is one in a series. We've gone through how to wire up, how to power your flight controller, how to wire up the motors, how to wire up the receiver, how to wire up telemetry, how to maybe a few other things I'm not even remembering right now. The link to the playlist is in the video description, and if you think this video is great, they're all just as good, so check them out. But in this video, we're going to talk about how to wire up the FPV camera and video transmitter. And if you fly an FPV quadcopter, then you're going to have these things. Those of you who fly line of sight can skip this video, unless you just like listening to me talk. I know a few of you are out there. The first thing you got to figure out is how to power your video transmitter and your camera. And in order to do that, you've got to look at what the input voltage range is for those devices. And every electronic device is going to have an acceptable input voltage range, and you can look on the video transmitter. Sometimes it's printed on the video transmitter. So we can see here that UniFi Pro 5.8 gig high volt, it says 7 volts to 26 volts here. You need to give this video transmitter an input voltage between 7 and 26 volts. If you give it less than that, it won't work properly. By the way, sometimes if you give a low input voltage, the device will power up and appear to work, but then it'll get all glitchy and weird. But then eventually, if the input voltage is too low, it won't even power up. And if the input voltage is too high, the smoke will come out, so you don't want that. Here on the tramp, the Immersion RC tramp, we can see it says 6 to 18 volts. Okay, so that's basically between 2 and 4S voltage. And here on the RunCam Swift, it says 5 to 17 volts. So the RunCam Swift is basically 2 to 4S, but also it can get down to 5 volts if you're trying to run it off the 5-volt regulator that many of our flight control boards have. So we have to figure out what the input voltage range is. Now I've picked these 3 examples, but in general, most recent cameras can accept 4S at least, or maybe even as much as 6S voltage directly. A lot of the newer run cams will take up to 36 volts, and that's basically more 5S and even 6S voltage. We're good to go. Older cameras tended to accept only 12 volts or maybe even 5 volts, and they were just locked in. I'm thinking of like the PZ042, whatever. In those days, you had to have a 12-volt or a 5-volt regulator depending on what your camera could take, and the cameras tended not to have a wide voltage range that they could accept. Many video transmitters will take up to 4S or 6S, but not all of them. You really can't assume. Like the cameras, you're kind of safe assuming they all go to 4S, but not all video transmitters will do that. Most notably, the UniFi Pro, which is a very, very popular video transmitter, only takes 5-volt input power. So, if the input voltage range is not printed on the unit, then you got to search for the product page or manual for the unit. What I like to do is search for RunCam Swift specs or specifications, or just go look for a product page of anybody who is selling it, and quite often the specs will be there and the input voltage will be listed. Now, there's a decision you have to make about your video transmitter and your camera. You have to decide if you're going to power them from regulated voltage or from unregulated battery voltage. If your video transmitter accepts a lower voltage like 5 or 12 volts, then you really have no choice but to power it from a voltage regulator. Likewise, if your video transmitter only goes up to 4S, but you're running, say, 5S or 6S, you'll need a regulator to step that down. But frankly, in that case, you might be better off just to pick a different video transmitter, because this quadcopter gets a little clunky as you start adding voltage regulators. It just depends on what's already on the copter, depending on your PDB or on your flight controller. You might have a regulator that puts out the voltage that you need. If your video transmitter is capable of accepting whatever battery voltage you happen to be using, you can still choose to power it from a regulator if you want to. So let's say you've got a video transmitter that takes up to 18 volts. you might elect to run it off of a 12-volt regulator, and there's some advantages to that. Powering a video transmitter off a regulator adds filtering. The regulator itself filters out the noise because if you think about it, noise is spikes in voltage. And a regulator's job is to put out a consistent voltage. So if the noise is spiking around, the regulator filters that noise and you get relatively clean 12 volts or whatever it's putting out. But that's not always necessary. Sometimes you're just making a good thing not that much better. If the video transmitter itself has enough filtering built in, the designers of the video transmitter have given it enough capacitors and inductors and whatever else they're doing, diodes, to filter the video, then you've already got great video, and having more filtering doesn't really help you. It doesn't really hurt you either, though. Powering the video transmitter off of battery voltage definitely simplifies things. My favorite video transmitter to use right now is the Unify Pro HV, or Unify Race HV. It's the high volt Unify. And I like it because I just don't have to think about, do I have a big enough regulator? What's the input? If I just wire it up to VBAT and get on with my day, there's certainly something to be said for that. But if I had a very noisy copter with lots of unimbalanced motors, or just some ESCs that were making a lot of noise, I might wish I had a little more filtering and I could run it off. That's the great thing about a VBAT capable video transmitter, is you can always choose to run it off a regulator if you want. So it's kind of the best of both worlds. If you power your video transmitter off of a voltage regulator, you have to ensure that the regulator has a high enough current rating. So you'll see manufacturers say that a PDB or a flight controller has a 1.2 amp 5-volt regulator. And what that means is that you can draw safely up to 1.2 amps from that regulator, and it will not burn itself up and destroy itself. But if you draw more than 1.2 amps from the regulator, then you're risking damaging it. That is not a hard line. It really usually goes back to the heat dissipation. So if you're flying in a really cold environment, you may find that a 1.2 amp rated regulator can safely run at 1.5 amps and you not have any problems. And likewise, if you're running in a really hot environment, you might find the opposite. You will damage the regulator before you reach the rated amperage. The other thing to keep in mind is that amperage rating is not just for your video transmitter. So if you have a 1.2 amp 5-volt regulator on the flight controller, well, the flight controller itself is using some of that current. The receiver is using some of that current. If you have LEDs on board and you're running them off, that's all eating into that. So don't assume that you have that whole 1.2 amps. You're losing some to the system. You definitely want to oversize the regulators if at all possible, and have as big a regulator as you can feel like you can get away with. Figuring out how much current your video transmitter pulls can be really tricky. And the reason for that is that you'll see vendors and they'll say this video transmitter pulls 200 milliamps. But the device's input current, how much current it pulls, will change as its supply voltage changes. So if you have higher volts, you'll pull fewer amps. If you have lower volts, you'll pull more amps. And especially that's true if you're running off of VBAT, but because the battery voltage will change over the course of the flight and the current will go up slightly. But it also, if you're choosing to, whether you're going to run it, they might say it pulls 200 milliamps at 12 volts, but they're not telling you that the 12 volts is assumed. So if you're running on 4S, it's going to pull less, and if you're running on 2S, then it's going to pull more, and you just don't know what that is. If you have a clamp meter, you can use it to find the actual current that the video transmitter is drawing. You'll just put your clamp meter clamp around the wire, the power wire going into the video transmitter. You'll power it up, and you'll see how much current it's drawing. Remember that increasing the output power of the video transmitter increases how much current it will draw. So if you've got a variable power video transmitter, if you find that it pulls 100 milliamps at 200 milliwatts output power, but then you put it up to 800 milliwatts output power, then you're going to pull a lot more. And you've got to remember that when you're thinking about how big your voltage regulator needs to be. In general, if you were to allocate 600 milliamps for any video transmitter under, let's say, 800 milliwatts output power, you're probably going to be okay. You might not be pulling anywhere near that. But that's, I think, a safe rule of thumb. And if you feel like just skipping all this nonsense, assume your video transmitter pulls 600 milliamps. Assume your camera pulls around 100, maybe 120 milliamps. And if you then double that number for everything else on your quad, and you're probably all right. Most of you out there with a 1.2 amp or a 1.5 amp regulator, even if you're using a really big video transmitter like the Unify 5 volt that pulls a lot of current, if you have around a 1.5 amp regulator, you'll probably be okay. 1.2 amp regulator, you're probably getting a little close to the edge depending on what else. Don't try and run a bunch of LEDs and a Unify Pro 5 volt on a quad that has 5 volt regulator to 1.2 amp 5 volt regulator. You might not be big enough. And if you're bigger than about 1.5 or 2 amps on your regulator, then you probably are fine. Now we start to talk about where to wire up the video wires. And we start to see a weird thing called the RAM pin. And we're looking here at a Betaflight F3, and you can see I've circled here the RAM pin. Now that is the origin of the term RAM is actually a misspelling. I forget I think it came from the Omnibus board, and I guess that would mean the designer was Nathan Soy, although I'm not 100% sure I'm attributing the story correctly. But the designer of the board meant to call it something else and misspelled it, and then by the time the boards came back from the manufacturer, now it's the RAM pin, and we live with that forevermore. This pin's purpose is to provide dedicated power for the video transmitter and the camera. Now, on a board like the Omnibus, I think that the RAM pin is not filtered on the Omnibus, but I'm not sure about that. It simply provides a convenient way of feeding a certain voltage to those devices without having to just wire them directly to the regulator. On the Betaflight F3, though, the RAM pin is filtered, and the idea there is that the camera and the video transmitter need particularly clean power so that you can get nice clean video without a bunch of lines in it. It's possible that the RAM pin on the Omnibus is also filtered, so if I'm wrong about that, well, now I've covered my bases. The voltage that the RAM pin puts out varies, and how you select it depends on what the designer of the board has given you. So on the Omnibus, there's a RAM pin in the camera header and video transmitter header that you solder them to, and then elsewhere on the board there's a RAM pin, and right next to it is a 5 volt and a VBAT pin, and you bridge the 5 volt or the VBAT pin to the RAM pin to feed voltage onto it depending on which one you want to feed to the camera. In the Betaflight F3, there's a solder bridge that lets you pick whether the RAM pin gets VBAT or 5 volts. Whenever the flight controller gives you a dedicated power pad, like the RAM pin, that's dedicated to the camera and VTX, you should probably use it. You could certainly just wire your video transmitter and your camera straight to the battery pad. But the advantage of the RAM pin or a dedicated camera pin or something like that is that it's oftentimes going to have filtering on it to give you cleaner video, and you definitely want that. Some video transmitters will have a built-in regulator which allows them to output voltage to the camera. And this goes back to the days when cameras tended to be 5 volt only. So you'd have a video transmitter that would take VBAT in, and then where are you going to get 5 volts for your camera? Oh, who wants to put a 5 volt regulator on? Well, the video transmitter gives you a convenient 5 volt regulator. Here we can see the Unify Pro high volt. It puts 5 volt out, and you can run that into your camera to power your camera straight off the Unify. These days, though, the flight controller or the PDB is almost always going to have the regulator that you're using, and this is not, I think you should just use that instead of using this, if only because it keeps your wiring clean. We'll see some wiring examples coming up in a minute, but basically, if you run all your wiring to the PDB, it's much cleaner than if you've got all your wiring to the PDB except for this one wire that's going over to the video transmitter to get 5 volt power for the camera. Now, here are my personal best practices for getting clean video. This is not the only way to get clean video, but I have pretty clean video on basically every copter I build, so I think I might be doing something right. Number one, use a video transmitter and a camera that can both take VBAT input voltage. So you want to just run them straight off the battery. And the main reason I do this is because it's annoying to have to think about is my regulator big enough? Is it too small? I just want to build the freaking copter and get in the air. And if both the video transmitter and the camera take VBAT voltage, then I don't have to think about that. Wire the video transmitter and the camera to VBAT, or if you have a filtered RAM pin that can output VBAT voltage, wire them to the RAM pin, like the Betaflight F3. Always connect the video transmitter and the camera ground to the exact same pad. This is a big one. This is so much more important than many of you probably realize. I had one copter. It was a Raceflight Revolt and what was it was an Acon 30 amp ESC, and on that ESC I was running the camera and the video transmitter off of VBAT, and the ground wire for the camera and the video transmitter was soldered to a ground pad on the other side of the Acon ESC. So there was literally 31 millimeters between those pads, and whenever you would throttle up, the camera would drop out. And I tried everything. I replaced the video transmitter, I checked all the wiring, and you know what finally fixed it? Moving the ground wire for the camera over to the same pad as the video transmitter's ground wire. That was something about the ground potential across that board was causing the camera to drop out. So you'll get away with this so many times, but then the one time you have problems, you're not getting away with it, so just do it right from the beginning. Always run the camera and the video transmitter ground wire. Twist them together, tin them, and solder them wherever you're getting ground from to the exact same place. It'll clean up your video a lot of times. If the flight controller or PDB has a large enough voltage regulator, then I will consider using it instead of VBAT. And what I'm thinking about here is some of these, the CL Racing F4, for example, has like a 7.2 volt or 7.6 volt regulator on it specifically for the video transmitter and the camera. And you might think, well, that's pretty weird. If they can take VBAT, why would you ever feed them off of 7 volts? And the answer to that is that the regulator is filtering, and the lower the output voltage of the regulator, the better it filters. So the idea is you run them off that regulator, it improves your filtering, it improves your video quality, and that's a good thing. Assuming the regulator is big enough, which of course in the case of the CL Racing F4, it's specifically designed to be big enough. Although I will point out, there's people out there who are running a Unify and a RunCam split. And the RunCam split, it's not your typical FPV camera, right? It's a high def camera. It's doing all this fancy stuff. Your typical FPV camera, like a RunCam Swift or a Foxy or Arrow or Monster, is going to pull in around 100 to 120 milliamps at most. The RunCam split pulls like 650 milliamps. And so in that case, a regulator that is designed specifically to feed a video transmitter and camera may not be expecting that big of a current draw. You always got to think about how big the regulator is and how much power it can provide. So now we're going to look at some examples, some wiring examples, and I could make a ton of these, but I've only made 4 of these. So I think they show the most common types of setups that you could run into, and hopefully from here you can start to kind of extrapolate how to do other ones. But I feel a little bit bad about this section because my goal in all of these sections is to teach you to figure this out on your own and to know everything you need to know to do this by yourself. And this is the one section where I kind of feel like I can't fully accomplish that because there's just so many different flight controllers, cameras, video transmitters out there. We're going to do our best though, and hopefully it'll be enough. So our first example is a Betaflight F3 flight controller with a Unify HV, and this is the most common thing that I'm building right now, although I am starting to transition over to F4 boards, but most of the stuff that I build is still this exact setup that you're looking at here. And what I do is, first, I set the RAM solder bridge to VBAT, which causes the RAM pin to have VBAT on it, but it's filtered VBAT. And then I run the power for the camera and the video transmitter to the RAM pin, so they're powered straight off of VBAT. I run the ground wire to the AGND pad, that's the ground pad that corresponds to the RAM pin. And then I run the signal wires, and this is the easy part. You'll have a V out and a V in, and V in comes from the camera, and V out goes to the transmitter. Now, you have V out and you have V in because the Betaflight F3 has an OSD. So the camera needs to come in, and the OSD needs to be inserted into the feed, and then the resulting feed with the OSD on it needs to go out to the video transmitter. If we didn't have an OSD, we could just wire the camera straight to the video transmitter and skip the flight controller altogether. We'll see an example of that in just a minute. By the way, I've also included here the smart audio wire from the video transmitter. And that has nothing to do with the video, but I thought as long as I was showing this wiring diagram, it would kind of be an oversight to leave it out. Running smart audio wire to TX1 or TX3, depending on which you prefer to use. There isn't really a difference on this flight controller. Here we've got a Unify Pro, and the difference between this example and the previous one is that the Unify Pro only takes 5 volt input power. So in this case, everything is the same. Of course, the V out and the V in are the same. That's not going to change, and the smart audio is the same. The ground and the power have changed, though. That's the difference. Now, we've still set the RAM pin to VBAT. And you might think that since the Unify takes 5 volts, we would want the RAM pin feeding filtered 5 volts to the Unify. Well, that would make a lot of sense. The reason that we can't do that is that the filter circuit, it includes, like, it has a diode in it, and that maximum current rating for that diode is about 600 milliamps. And the Unify the Unify Pro at the highest output powers, 600, 800 milliwatts, will pull too much current, especially when you combine it with the 100 milliamps or so of the camera. It'll pull too much current and it'll actually burn out the RAM pin. And if you look around on RC groups and Facebook, you can hear people saying, Betaflight F3 sucks, the RAM pin stopped working. And I don't know for sure what the scenario is, but I'll bet you they were pulling too much current through that circuit and they burned out the filter circuit. Well, don't read the manual. you get what you get. So what we've done here is I'm running the camera off the RAM pin. And the reason for that is that the most important thing for good video, in my experience, is that the camera get good filtered power. The video transmitter will usually be able to deal with a little bit of dirty power, but the camera, if you give it dirty power, you're going to get terrible video noise in the video. So I want the camera run off of filtered VBAT, and it goes to the RAM pin. And then the 5-volt pad just underneath it. Now that's just a handy 5-volt. You could use any of the 5-volt pads anywhere on the board. There's tons of them. Just pick one and solder the Unify to that. The regulator on the Betaflight F3 is rated at 3 amps. And the manufacturer says that if you assume that the board itself is going to use as much as 1 amp of that, which means you have 2 amps left over to play with for all of your accessories. There's more than enough capacity on that regulator to handle the 600 or so milliamps that this board is going to pull. Here we've got an example of the CL Racing F4 and the Race Day Quads Mach 1. I didn't have room to put the text over there, but that's the Mach 1 transmitter from Race Day Quads. Now, one thing about this transmitter you'll notice is it doesn't have the smart audio wire because it doesn't support smart audio. But this is a great basic example of wiring up a flight controller that doesn't have like the RAM pin and all those nuances. And it's actually pretty simple. The camera power goes to, we can see here, the camera, it's labeled Cam Plus. So there's Cam Plus, Cam Minus, and Cam S, which stands for Cam Signal. This is a little bit unconventional. You'll see more boards labeled with like V in, V out, and just, 5-volt. But here they've labeled it Cam Plus, Cam Minus, and Cam _S for signal. And likewise, we've got VTX plus, VTX minus, and VTX signal. Just wire those up, you're good to go. In this example, we've got the Rotor Geeks SSD and the Maytech Hub OSD. That's PDB and OSD together. And this is an example of a case where the flight controller doesn't have an OSD on it. Okay, so I've put it in the diagram, but you can see there's no wires going to it, right? It's not really part of the video, the FPV feed. We're running power to the VCC pad, and that means that VCC is another word for VBAT, or battery voltage, VCC. So I've elected to run these guys off of battery voltage. However, if we look at the input voltage range, we can see it's 6 to 28 volts for the Aomway video transmitter, and of course it's 5 to 17 volts for the RunCam Swift. We certainly could elect to run these off of, well, we can't do 5 volts because that's too low for the Aomway. So we could certainly elect to run them off of 12 volts if we wanted a little bit more filtering, but we would need to check the current rating for the Hub OSD to see that its 12-volt regulator had enough power to add enough current to supply these. And then we're running the video wires to the VTX and the cam pads. So in this case, instead of labeling them V in and V out, they labeled them cam and VTX. But of course, that's for the camera signal and the VTX signal wire. And then ground is going to any convenient ground pad, but they're going to the same ground pad. That's important. You might be tempted to run the camera to this ground pad and the VTX to, this ground pad. Don't do it. The same ground pad. There's one more example that I haven't made a diagram for, and that's the case where you don't have an OSD at all. And that's increasingly uncommon these days, but I know some of you out there are flying without an OSD. If you don't have an OSD at all, then you're going to just take the video wire from the camera and connect it directly to the video wire from the video transmitter. They're just going to solder together. They won't get soldered to a PDB or anything like that. You actually do find a few PDBs that don't have an OSD. They just give you a convenient pad to solder to, because splicing a wire is a little bit messy and soldering to a PDB is much neater. So you'll see some simple PDBs with no OSD, and they'll have a cam and a VTX pad, but you're just hooking two wires together. That's all there is to it. That's going to bring us to the end of this video. I hope now you have a better idea of what goes into deciding where to wire up and how to wire up your video transmitter and your camera, and also the question of which video transmitter and which camera you're going to pick. And that's the reason why this isn't a video where I can show you every possible permutation. You got to think about what kind of input voltage the video transmitter is going to take and what kind of output current your particular PDB and flight controller can provide. For example, the RotorGeeks SSD is a fantastic flight controller. It's got a massive 5-volt regulator. I think it's a 5-amp 5-volt regulator. I'm sure it's at least 3 amps though. I don't know. But you couldn't run that though with that Aomway video transmitter that I showed you, because it requires at least 6 volts of input power. So that wouldn't be a good video transmitter to choose. However, if you've got the RotorGeeks SSD with the massive 5-volt regulator, it would be great to run that off of, say, a Unify Pro. They're tailor-made for each other. So you just got to think about how all these parts are going to fit together when you're selecting. And usually you're going to pick the flight controller first and the video transmitter second. And I just get something that runs off of VBAT and just be done with it. Thanks for watching. Leave any questions down in the comments. Anything you think I missed or anything you didn't understand, I'm happy to answer. I'm answering questions all day long, and I really love doing it. So if you guys learn something, that's really what's in it for me. Thanks for watching. Happy flying.